Okay, today's objective is to graph linear equations and find the slope. So we're going to start by graphing. First of all, linear means that it's straight lines. So to graph 3x plus 4y equals 12, we have to solve for y. To solve for y, you move the 3x to the other side. By subtracting it, and then you divide by 4 everywhere. Divide by 4, divide by 4, divide by 4. So you get y equals negative 3/4 x plus 3. This negative 3/4 is called the slope. This 3 is called the y-intercept. Slope is where you begin, or y-intercept is where you begin, slope is how you move. So let's sketch a graph. So if my y-intercept is 3, I go to the y-axis, find 3, and I put a dot. Now my slope is negative 3/4. Slope is rise over run, so the top number is negative, so I'm going to go down. Bottom number is positive, so I'm going to go to the right. Now, if I didn't want to go down and to the right, I could also go up 3 and to the left 4. And it would all be the same. Connect your dots, and there's our line. So to graph linear equations, you solve for y, get it so it's y equals mx plus b. Start with your b, then move according to your m. So slope, I said, was rise over run, but there's also a formula. M equals y2 minus y1 over x2 minus x1. That means second y minus first y, second x minus first x. And you always leave it as a simplified fraction. You don't usually write slope as decimals or mixed numbers. So in example 2, we need to sketch a line that has a positive slope, a negative slope, a zero slope, and an undefined slope. So I usually talk about slope as with a mountain. So positive slope is you're climbing up the mountain. Negative slope, you're going down the mountain. You're falling down the mountain, having to roll down it. Zero slope is like the floor. It's a horizontal line. Undefined slope is a vertical line. So undefined is a vertical line. So horizontal is 0, undefined is vertical. So the floor has a 0 slope because it's horizontal. You can slide right across. The wall has an undefined slope because you can't climb up the wall. Okay, example 3, find the slope of the line passing through 1/2, 3/4, and 2/3, 4/5. We have to use our slope formula on this one. So it's x1, y1, x2, y2. So then we plug into our formula, y2 minus y1, so 4/5 minus 3/4 over 2/3 minus 1/2. Now, I'm going to ignore the bottom and just focus on the top. So focus on the numerator, 4/5 minus 3/4. In order to subtract fractions, you have to find a common denominator. Common denominator for 5 and 4 is 20. So 5 times 4 is 20, so 4 times 4 is 16. 4 times 5 is 20, 3 times 5 is 15. So 16/20 minus 15/20 is 1/20. On the bottom, 2/3 minus 1/2, the common denominator is 6. So 3 times what's 6? 2, so 2 times 2 is 4. 2 times 3 is 6, so 1 times 3 is 3. 4/6 minus 3/6 is 1/6. So I have a fraction over a fraction. What that really means is 1/20 divided by 1/6. So that problem means 1/20 divided by 1/6. So let's think back to how we divide with fractions. You keep the first one the same, then you multiply by the reciprocal. Reciprocal means flip it over. So take 1/6, flip it over, and multiply. When we multiply, we go straight across. 1 times 6 is 6, 20 times 1 is 20, and then we reduce. 6 over 20 reduces to 3/10. So in example 4, we need to find the slope of the given line. To find the slope of a line, you count. You pick a point to start at, and you count from there to the other point. So I'm going to start at this point on the left. I'm going to go up 1, up 1, 2, 3, 4. So going up is positive. Then I'm going to go to the right 1, 2, 3, 4, 5, 6. So up 4 and right 6 is 4 over 6, and I reduce that to 2/3. Now if I had started over here on the right and wanted to go to the left, I would go down 1, 2, 3, 4, and to the left 1, 2, 3, 4, 5, 6. Both of those are negative, and negative makes a positive. Negative 4 over 6 reduces to positive 2/3. So I get the same answer no matter where I start. If I had used this point in the middle, I would have gotten up 2 and over, and over 3. So I would have gotten the exact same answer. Okay, your assignment today that goes with this is assignment number 8, page 69 through 70, numbers 5 through 17, 34 through 37.